Okay, let's say we have two squares here. Now these, you got a big square and a small square. Okay, these are all the same. It's a square. And here's a smaller square. Now let's just pretend this as an example. Let's say this here is, I don't know, let's say it's 16 centimeters. So that side length is 16, and let's make this one, let's make it 4 centimeters. 4 centimeters. Okay, so what is the ratio? What is the ratio of their side lengths? So I can write a ratio as a fraction, and I'll just say um, I'll just say I'll put the big one on top. It doesn't really matter, but let's put the big one on top here. So the big side length is 16 centimeters, and the little one is 4 centimeters. So when I divide, I get 4. So when I divide, I get the ratio of their side lengths is going to be 4. Okay, and this is called a one-dimensional ratio because I have centimeters is a one-dimensional length. 4 centimeters, it's one-dimensional, it's a length. So we can call this the 1D ratio. The 1D ratio, like that. Now, I could do the same thing with perimeter. Let's find the perimeter. Let's find the perimeter of this. So what's the perimeter of this big square here? Well, it's just 16 times 4, that's 32, 64 centimeters, right? And if I find the perimeter of this one, well, 4 times 4 is 16. So the perimeter here is 16 centimeters. So I should use a different P here. Let's put P for the big one. I can make this like that. And this one is the small one. Put a little S for small. Like that. The perimeter of the small one. Like this. Okay. So let's find the ratio of perimeters. So here let me just write, this is a ratio of the sides. Okay. And now that's a 1D ratio. Okay. And here perimeter is measured in centimeters. And so is this one, obviously. They're both measured in centimeters. I'll go over here. And let's take the ratio. Let's take the ratio of perimeters. Perimeter. And I'll get, well, 64. It's too big on top again. So I'll get 64 centimeters on top. And at the bottom, I'll have 16 centimeters. If I take that ratio, if I divide, I will get 4 again. It's still 4. Well, we knew it was going to be 4 because it's also a 1D ratio. It's a 1D ratio. So that's going to be 4. It's still a 1D ratio. Okay, like that. Let's put this over here. Like that. Now, what would happen if we take the areas? Now, let's take the area. So the perimeter of the small one is 4 times the perimeter of the big one. So if I just go like this, the perimeter is 4 times. Right? The perimeter is 4 times. If I go like that, I multiply by 4. I multiply the perimeter by 4. Now what happens if I take the area? Let's take this whole thing again. This time, let's do the area. Let's find the area. Okay, so I'll rewrite the whole thing. Now this time, I'm going to get rid of this. Get rid of this. And let's see if, let's put a question mark here. Let's just keep that over here for a second. So what is the area of the big one? Well, the area is going to be 16 times 16. 16 times 16. It's going to be 256 centimeters squared, right? So it's 256 centimeters squared. Okay, and what is the area of the smaller one? The area of the smaller one is going to be 4 times 4, which is 16 centimeters squared. And now what we're going to do is find the ratio of areas. So let's find the ratio of areas. Ratio of areas. So again, I'll do the big one on top, little one at the bottom. So the area on top is 256 centimeters squared, and the bottom is going to be 16 centimeters squared. 16 centimeters squared. So I'll just do that like this, and I'll write over here 16 centimeters squared. Okay, so we notice that when we divide, do we get the same ratio as before? Well, this is a 2D ratio because I'm comparing two-dimensional measurement. So we don't get 4, but we get 20. It's 16. When we divide this, we get 16. So the 2D ratio, two-dimensional ratio, is equal to 16. Okay, so it's not times 4. It's going to be times 16 over here. So here it'll be times 16. Okay, so how do we get from 1D to 2D? What do we do to the 1D ratio to get to 2D ratio? Now let's do the whole thing again, and we'll do the whole thing again with volume in the next video.